spinning of some of the things, like the headstock, the tailstock, the tool rest, the fulcrum pin. Those are really helpful. And then this is just some diagrams that I took out of a book from about 1908 on the spinning process. So for me, when I was in graduate school, I spent a lot of time doing research and found most of my information on metal spinning and patinas were in books that were printed 1890 up to about 1920. So anyway, maybe this will be helpful for you. Maybe not. There's a sectional breakdown check, which is a more elaborate system. I'm not even going to go into that.
Right.
And then when I was at the UW, I got a chance to teach some spinning while Mary was on leave, and there was a woman, Lynne Henry, which is different than myself, Lynne Hull. She designed this form to make hollow constructed bracelets. And if you guys have questions about this later, I can go over that, but I just thought they'd be good info for you. The other thing that I did want to mention is this is the company. It's One Way Manufacturing. They're a remarkable company. They started making parts for wood-turning lathes, and people kept complaining about the quality of lathes out there available, and so about 4 years ago, he built a large prototype, and things have just really taken off. So if anybody's really serious and wants to look into this company, I've got some of his catalogs here. They're not inexpensive, but they're the top of the line and they're the finest thing that I've used in the way of equipment. This little prototype with all the bells and whistles, the special chuck, and all that kind of stuff, he thinks is going to run, because this is his prototype. I mean, I literally got it down at the airport, picked it up Friday afternoon. He's been working on trying to get this built for this and another conference that's coming up. They're going to run about $1,200 American money, but it's an incredible piece of equipment. So I will leave these for you guys if you're interested. They are Canadian. They are based out of Toronto, outside of Toronto, Canada. And I won't say anything more about the lathes except that you have to have one if you're going to do this kind of work. Do you have one handout? You do. It just means we'll be short tomorrow. How come we're short today? Because Helen Pabula was supposed to be here today. She was on the roster, and I don't see her name.
She has someone standing in for her.
Oh, okay. Cool. Just a couple of things real quick, like I think most people are familiar with metal spinning on a really large scale. The lathe that I have is an 18-inch. Are we still short of? Or
no, I'm looking for a catalog.
Okay. You're welcome.
Yeah.
I would like to save half of them so that their people tomorrow might get half. If you're really dying and interested, I can give you their number. Yeah. What? They have a 1-800 number. It's the only business I know that doesn't have voicemail, though. So if you call at lunchtime, you won't get a hold of anybody. But I kind of like that. I'm not going to put a voicemail for somebody.
What is wrong with these smaller ones, what you see in some catalogs, this really tiny jewelry lathe? Is it worth look into it compared to...
We have some watchmaker lathes. They might not be strong enough structurally. There's a couple of things different. My first lathe that I bought was a 1909 American, that was the brand name, wood-turning lathe that was converted during World War II to a spinning lathe. And some of the conversions have to do with the bearings in the headstock and the tailstock, and then also the tool rest. So there's a few things that are a little bit different, but I have a little miniature lathe that I picked up that they used to make wooden dowels for furniture off of, and for a long time I worked on that for my little pieces. But having had this for a day and a half, I'm already going to have to order this little guy. So if anybody has any suggestions or advice or anything down the line, I know that he's already talking about maybe making it 4 inches longer so that you can turn spindles. And I'll talk about that in a moment. But you can adapt them over. What you might end up doing is having to replace the bearing head in it and the tailstock part. And those are all parts that if you have...
And I have a very tiny one from what is made in Germany, what I have my eye on. But to bring it over is a pain.
Well, and that's the problem out there. There aren't good quality lathes being made today. And so that's why I was thrilled to find this fella and have an opportunity to have one in my own studio. And I had a serious accident last fall, and I can say because of my new lathe, I still have my finger. If I'd had my old lathe, I wouldn't still have it. So after 18 years, I was doing something stupid. So I also want to say to you, this is the first time I've demonstrated since then. So it's a little unnerving, but things will go well. It was one of those instances where I knew exactly what I did wrong. I'll never do it again. So it's in hindsight. But I did want to share with you some things in the way of scale, jewelry scale stuff that I did. I made this piece for myself about 5 years ago, and of course hung it on snake chain. But that's beginning of the smaller scale stuff that I started building. Every year for Christmas, we have an ornament exchange with our guild. So this was one of the ornaments I made, and after hours of building this thing, I could have bought a plastic one for $1.99. But anyway, this part is spun on it. And then a couple of years ago, I did bells, which was really fun. So small scale stuff, and I'll pass that one around. In hindsight, bronze is an incredible metal for sound. I'm doing that one. And then I do have, they're kind of beat up, but I do have a couple pairs of earrings that have been lying around and are dirty at this point that I wanted to share with you. And then these were some hair ties at one time that I did that are also spun parts that are altered. So what I'm not seeing that I would love to see is people that are using this process for jewelry making for really tiny stuff. Oh, here's my other one too. First ornament. So for the demonstration purposes, all of my wooden patterns don't fit on this lathe. So as I was working with it this weekend, I decided instead of going really small that I would go big enough so you guys can see what's going on here, and then just let you know that in this box is where I have all kinds of wooden patterns from the past. And when I talk about wooden patterns, these are the forms that you make to produce, to press the metal over. And so these are pretty tiny. I think you can get a chance to see that you can work really small. If you were going to produce more than 15 or 20 of something, I would consider turning these out of brass or out of steel for strength. But I use hardwood maple. It's what traditionally has always been used for metal spinning. You can use oak, but what I found is the grain of the oak shows up on the inside of the metal when you're done. So you really want a hard wood that has no grain to it. So birch is a pretty good wood for that also. So that kind of gives you some ideas of the possibilities. And then I've always had people say to me, well, with metal spinning, it's so limiting. There's nothing, what can you do with it after you get it, you make the form. And it's like, well, once you've got the form, then you can alter them and do all kinds of stuff with them. You've basically raised up a form that then you can play around with and go back in and rework. So these were a couple of things that I did Saturday, hoping that I could use this lathe and we'd have some success. Some cups, little small guys that I can pass around. And this one was one I was playing around with the idea of trying to do a container with a lid that fit down inside without having to use more than one pattern. And I don't know if it's going to work or not. Are there any questions so far? Are people familiar with metal spinning? It's a process that's used in industry for a very long time, and actually, once again, the Chinese invented it. And even they found evidence that both the Greeks and Romans used it for forming. I was lucky enough when I was in graduate school in Rochester, New York, studying with Hans Christensen and Jerry Griffin to stumble across the spinning process and fell in love with it. It's like throwing on a potter's wheel. You have an opportunity to produce some things pretty quickly. It's also like throwing on a potter's wheel where you're going to take a long time to get good at it. So it's practice, practice, practice. And even when I was working on this new lathe the other day, I had some typical things that happen from the spinning end of it. And this is where you tear out the bottom. So I got that. This is one where I pushed it past its annealing temperature, or its working ability, and it needed to be annealed. And it stiffened up and wrinkled on me. It's savable, but I thought I got to keep it to show you guys. And then this is an example of, with the cutting tool, catching the edge of it and tearing it. So when I first learned how to spin metal, I probably went through a garbage can full of aluminum, because aluminum is a really good material to learn to practice on. And so you kind of have to have that sense. But what I was hoping today was maybe to inspire people to go back, look if they have an old lathe, see about adapting it over, and start playing around with the process. The first thing you need to know about metal spinning is you need to know how to turn wood. And I've been involved and worked with a lot of the wood turning groups around the country and in Canada for several years now. And they've sort of adopted me as a wood turner, although I would call myself a hack wood turner. I can basically get my forms down to what I need them to be to do what I do here, but I certainly by no means can turn bowls like those people do. They're pretty incredible. So anyway, that's the first thing that you're going to need to do once you get a lathe is you're going to need to have some turning tools. And I probably about 4 months ago purchased some of these small wood turning tools, which for the smaller scale stuff, and I would really encourage you guys to look into those if you're thinking about working on a smaller scale. And when I was up in Canada, I met a fellow who was actually turning brass on his lathe too and using his wood turning tools, which was quite remarkable because I wasn't under the impression that that could happen. So these are the wood turning tools that I'm going to be using. And then the tools that you need for spinning are pretty difficult to find out there. And I'm in the process, once again, working with One Way Lathe to have him start manufacturing them. But I built these about a week and a half ago so that I would have some samples for you guys. This is just regular drill rod that I purchased from a supplier here. They make drill bits. It comes already annealed, so I was able to grind, shape, and polish them into the shape that I wanted, and then harden them. Okay. And then the ends of them, I used my lathe to turn. This was an old handle off of a shovel. So I salvaged some dowling or handles and turned that. And then this is just copper pipe that I used, which is called a ferrule. And there's a hole that's drilled down into this, and then the piece is hammered down into here. And I don't know how involved you guys want me to get into this, but basically you heat this up to a couple hundred degrees, the steel piece, and you shove it down into the hole and it burns down in there and it seats itself in. The whole premise of this ferrule on here is to keep it from splitting and cracking, and it split and cracked anyway on me. But what you're basically going to need to have is a tool, and I think the handout shows pretty clearly the shapes of the handouts. But this is basically your forming tool. It comes out to a nice point on the end there, and that's going to allow you to do some of the forming. And then for smoothing, refinishing, you've got a tool that basically has got a flat head on it. So it's kind of like a planishing hammer is a little bit flatter and not as curved for that end. And then I've got one more that's kind of got a hook to it so that I can get down inside things. And I will also pass those around for you to look at. The handles aren't worn in yet. I also have some that are even smaller and one that's even bigger. So depending on what scale I work in. And these were the ones that I made when I first got out of graduate school. And they're pretty well used and tired. And this one works great for the really tiny little stuff. So I don't know if people want to look at those or not. And then one last thing about tools. I did a workshop at Cranbrook for Gary, who I studied with, Griffin, and he made me this wonderful cutting tool. And it's a little big for this lathe, but he's got it so that it's got some set screws in here, and this is basically a lathe bit. So I'm able to take it out, grind it, shape it, and I can put in different bits into it. And it really has made my life so much easier when it comes to trimming the copper, brass, and bronzes on here. So I'll pass this one around for you to take a look at. And I finally called him up and asked him how he made it, and he said, well, I drilled a hole into the end of it, and then I that was big enough that I could put the hardened bit in, and then he put the hardened bit in after he got the steel part red hot. So as he hammered it, it closed up and made a square hole. It was like, Gary, how'd you get that square hole in there? So anyway, it's a wonderful tool that I really appreciate Gary having made for me. Because what I use basically for trimming is basically a wood turning scraper that I've ground just a steeper head on it. And it works fine for a lot of things. It just doesn't have the structural strength that thing has for the bigger pieces. So I don't want to discourage people about having to make tools or finding tools or make it happen. because there's a lot of forming that you can do. I know people that spin pewter, and they basically use the ends of a baseball bat. And you can form copper and brass and silver with wooden tools, so you could get out and shape yourself something like that. And plus, they're out there. You can find those kind of tools. The next thing I probably need to mention to you, I feel funny standing up on this pedestal, is the way that you go about mounting things on here. Traditionally, my old lathe had what is called a faceplate. And basically, it threads right on to the headstock of the lathe, and you bolt your wood on. And it works pretty good. Since I was enlightened with the one-way lathe, they have a 3-jaw chuck here, or this is a 4-jaw chuck, that allows you just to take a piece of wood that's turned already and just clamp it in there and work off of that. The other thing that they've devised that's really wonderful is a way where you can take a piece of wood, drill the right size hole in it, and screw it onto the head of this lathe. And I think that's what I'm going to do for you today. And then I'm going to turn a piece of wood, and then we're going to spin some metal. Normally I have a design all laid out for this, and I really don't. You know, when I go to decide to do something, I pretty much have a profile drawing of what I'm looking for. And I know what I'm going to go after with the lathe. I kind of decided today that what I do is just set it up and turn some wood, and what we ended up with, we do.
I have a question. Why are they so long? Because the shape of these ends are like burnishers. Is that you have more?
Because you're going to need that under your arm for weight to push the metal around.
Good.
You're going to need the leverage on it. That's a really good question. When you see the actual process of it, it'll make a little bit more sense. But the way that this chuck works is they've got this bolt that clamps into the inside here, and then it allows us to screw on wood, which is a much faster way than using the faceplate. It also allows you to work quite a bit smaller. See how good I do with this new lathe. And then I can just take my piece of hardwood maple. I've drilled a hole that's smaller than the threads that are on here, and I can just screw this on. So that's on there, and I'm at this point ready to consider turning. The other thing that's different from a wood turning lathe or a watchmaker's lathe or whatever are the tool rests. This is for turning wood, and this is the one that we're going to be using for the spinning process. So he's devised mine. My tool rest is square, and he called and asked about specs on it. He said, "You really want a round one?" And I go, "I really do?" "Yeah, you really do." And so when it got here, I was a little hesitant, but the reality of it is he's right. This is a wonderful tool because that corner of the square piece doesn't get in the way when you're working with it. So that's something we should make for the UW. I know, they do need a new lathe. John didn't ask me about that when he bought that lathe. What?
Yeah, I know.
But at that time, I don't know if they were even making these lathes, so the Oliver was probably the best bet. So, are any of you guys familiar with turning wood? And it is part of the process. It's not the fun part for me because I like working in metal and forming it, but it is the necessary thing to get you to where you want to be. And so I'm going to kind of go through that. This is the tailstock, and the one thing that's different with the tailstock for a spinning lathe versus a wood turning lathe is that you have to have a live center so that this can spin too. And it's got to have a pin on it like this instead of a taper. Usually it's cone-shaped. To put what I call the follow block or the tailstock on the end here. And usually I get that set up and all ready to go. If you've never used a lathe before, the way that this is what's called a Morris taper, and it's a number 2. The way that you get them to come out is that you back up the spindle until it spits it out. And so to put it back in, you've got to open it up a little bit and then fit it down in there, and it's just pressure fit. This won't come out until I back this up, and then it just spits it right out. And that's true with all metal turning lathes. The other problem that I found with my old lathe, boy, this is really off center. is that I couldn't keep the tool rest or the tailstock tight enough, everything would slip. And this fellow has devised an incredibly sturdy way of locking things down for it. But if you ever are going to use a hammer on any of these kind of tools, you always want to use a rubber mallet or a brass hammerhead to lock it down or to unlock it. The other thing is I don't use gouges when I turn. I have a tendency to use scrapers. And most wood turners think I'm crazy because it's a slower process, but I think it was just the way that I was taught. And I'm not even going to go into all the differences on here, but there are gouges and then there are what are called scrapers. And that's what I use. And basically what you want this scraping tool to do is to be slightly above center so that you're scraping off the wood instead of gouging into it. So the height of your tool rest is pretty important. And in my studio, I try really hard to make sure that I'm wearing a dust mask or I've got a dust collecting system on here. For demonstration purposes, I'm just going to put on my visors wherever they are. Oh. And I also wear leather gloves because sometimes the chips that come off are hot. So the other thing that I really love about this lathe is that in every piece of equipment in my studio now I want to have like this because it's so wonderful. But when you turn this lathe on, do we have it? Oh, I know what I have to do. I have to turn the breaker on back here. I apologize. We kind of hot wired this for the workshop. He's got it on a rheostat, so when I turn it on, it can run that slow, or I can run it at any speed along the way. And several years ago, I was working with some ideas where I would spin up a form, and then I'd go in and cut bands off of it and then reassemble it, and they were basket-like. Now, my old lathe, I couldn't slow it down enough to do that, so this is really wonderful because you can go back in and really work the surface on your piece of metal because it runs so slow. The other thing that's really fabulous about it is it's computer programmed so that when you shut it off, it stops. It literally has a break for it. So unlike the buffer over there that continues to run, it shuts itself down, and that's really been a nice feature there. So I'm going to go ahead and sit up and turn some wood here for you guys. And you've done some of this, so if people start asking questions, you might
Sure.
at least say, well, Lynn, wait a minute. A lot of times what people don't like about turning wood is the corners, because the corners can chip and fly off. You guys will be fine. So one of the things you can do is you can pick up blanks like this already, or what I did on the bandsaw is I cut a lot of the corners off of this one. But for this, I'm going to come in and go ahead and turn it, because the wood turners that I know would say. The other thing I probably should do is put the tailstock on here just to make sure that it's holding everything in place. Not necessary because they turn wood balls. So the first part of the turning is always a little scary.
You really should walk around too to see how you can find the tool.
And the thing about something that's off center is it goes like this, so what you want to do is come in, catch a little bit of it, and then move nice and smooth right on the pallet.
Not enough.
And hardwood maple, even though it goes your tool fast, it turns beautifully. Couple things that are really important that I didn't mention. If you're ever nervous about working on a leg, one of the really important things to do is when you get it all set up and ready to do, is to do a full turn. That way you know you don't have the tool rest close to it and you're going to chip it and have it fly off. The other thing that you never do is use sandpaper when your tool rest is close at hand. That was the mistake I made as I was using sandpaper caught and sucked my finger down in there. So 5 months later and a skin graft and all of that, don't do it. And it's the first thing that any wood teacher will tell you to do. Don't use sandpaper without pulling your tool rest away. And I was working on a project that was for somebody else that I didn't want to be working on, and so it was my big lesson. So that's one of the things. The other thing is you just like when you're grinding tool steel on a grinding wheel or anything, once you start to get a big gap here, you got to move your tool rest in. so you don't catch anything. And then I'm going to do a full spin, make sure that I'm not catching anything. And then I can set it back up and get it running. Speed here, I've probably got it at about 900 RPMs. And the smaller the pieces, the faster you can turn them. This particular cutting tool allows me to work back and forth. The precision on it is, my old lathe was always off a little bit. And when it was turning, you could see that it was off. Once the pieces came off the lathe, you couldn't tell. But it's just so much easier on the body to be turning on something that's
I noticed when at least behind you that you didn't come all the way over.
I don't really want to ruin his one-way
Right,
track.
I understand.
Yeah. So I can probably go in and chew it up a little bit, but I think I'm going to spin something that's similar to a cone. Because a lot of the shallower forms are relatively easy to make, but the tall vertical forms are the ones that are difficult to spin. And it shows you the elasticity of the metal the best. So did I do my usual full turn here? And I'm going to make the base of my piece the same size as my tailstock here. Maybe it'll be a flower pot. Miniature flower pot. The hardest part for me is getting my physical strength back with my arm. I'm really still not even up to snuff there yet. But and then just always get in the habit of never running, or never keep it running while you're trying to adjust something. You just don't want your fingers that close. I just dropped the tool rest down a little bit so I could get in and get this last little bit here. Some other things that you need to know about the lathe is that when I first started teaching here, there was no forming tools at all. And so I spent quite a bit of time making little things like these so that people could form their sheet metal into. And so you've got a wooden form that can make you mandrels that you can shape things off of. You can make a lot of woodworking tools out of it. You can also turn all kinds of soft stones, turquoise, things like that. So it's really, for me, that's one of the things I want to start pursuing is turning some other things other than just metal on the lathe. But I've made a lot of tools for myself in my studio with this. Okay, so I've got that down approximately where I want. Now I'm going to come in with a scraper that's got a blunt end on it. And that's going to give me what I hope is a nice flat surface. It will allow me to get in there. Give myself pretty good surface to work on. So I'm probably pretty good up in, I'll be able to spin a form up to this point here. And then it's no longer round. One of the other things I've been thinking about lately doing is actually doing this and then going back in and carving into the wood. Spinning the form up, and the carving probably won't happen, won't show up in the metal, but afterwards then you can go back in with a hammer and chasing tools and develop that surface. And there's so many things that amazing possibilities that hopefully people will take and run with. Okay. One of the things I should mention to you about when you're working on a smaller scale, I've gone to using a steel tailstock. because when you start getting down under a 1/2 inch, the wood itself won't hold up for what we're doing here. So just to show you a couple of those things, because I did turn some things in. This was my tailstock. This is a form that I did for, which was those forms. So a nice big tailstock like that will really be helpful. When you start getting below a 1/2 inch, you've got to switch over to that. So I think I'm going to go ahead and just use this one here. And then I should dust some things off and then spin a piece of metal, and then I'll put a couple of different other forms on and show you some other possibilities. Let me get the balloon here. One of the things I also do is save all of my wood chips, and I use that for patina work.
Patina.
So if you happen to want to be doing sawdust patinas and you know a wood turner, boy, they'll be so glad that you'll come and take their wood away. Okay. This little edge may interfere and get in the way, but I think since this isn't actually my tool, I think I'm going to leave it and worry more about what will happen with the metal than worrying about the jaws here.
Did you ever try using a skew to cut things like that?
One of these?
Yeah.
Yeah,
But,
you probably could get in close.
I
think for the
That's pointed, isn't it?
Yeah.
I meant at an angle, a sharp angle like this.
So that you wouldn't get the tool close enough to it.
No,
to worry
use it as a knife. It works as a knife on the surface.
I know what you're talking about. I know which one. This. Is that what is that what they call a skew? Like I said, I'm not a wood turner. And every time I go into a demo, I always hold my breath.
on it than you have. I would guess. I use a little.
Oh. Well, then we'll.
Sit down here. No, I don't see a skew. I don't see a skew. This is a parting tool. Oh, here's a skew.
That's
a
what I
skew.
see.
That's a skew. I'm sorry.
Cool.
But you need one about that wide.
Yeah. Yeah, I just don't want to risk it on that. And it'll be fine for what we're doing. So now I've switched over to what is the tool rest for metal spinning, and these are what are called fulcrum pins. And they really are going to be the answer to what we're doing here. And he did a really great job in making this pin because the holes don't go all the way through, so the pins don't drop out, but they're in deep enough that they give you a lot of support. And then the next thing I've got some discs here. And one of the things that I found when having worked larger and then scaling things down is what I wasn't doing was scaling down the thickness of my metal. I was having a devil of a time on a smaller scale. So anytime I'm working with stuff that's 3-4 inches or smaller, I'm usually working 22, 24 gauge. Whereas my bigger pieces, I'm using 17, 18 gauge. And it really does make a difference. The other thing that really makes a difference is if you're going to be working with brass, being that it's that much stronger, or nickel silver, you can go down a gauge or two thinner with your harder metals and still have the structural strength, and you aren't going to have to just fight with them to get them to move over. I used to work in aluminum when I was learning how, and I would encourage you to do that, but if you don't know much about aluminums, what you want are aluminums that are formable. Here in Seattle, we've got aircraft aluminum, and aircraft aluminum is not malleable at all. That's the 7,000 series. And then we have the boat industry, and that's the 6,000 series. So what you need to do is get aluminum that's either pure aluminum, which is 1,100 series, or a 3,000 series. And that's what they make cookware out of, which is lots of times spun or hydraulically pressed. It's very difficult to find around here. The other thing is I found a while back that I just decided I didn't want to be working with aluminum in my studio anymore for my own health reasons. It might not have anything to do with it at all, but I've kind of gotten away from working with aluminum and the dust particles and stuff. So if you were going to use a metal that you might have access to in your studio, copper is a really good formable material to work with. Phil talked about malleability of metals this morning. Sort of the same kind of thing. Some of them are made. Yellow brass is what you want to use for forming. Other brasses are made for machining, and they won't form or bend for you at all. But copper's a good one to work with. And this is 24 gauge copper. I have a machine in my studio that's like a big can opener that cuts discs for me, and it leaves a little dimple in the middle. It's called a circle cutter by Peckstone. The other thing that you can do is take my favorite shears and cut them out by hand. That's what I do with those big shears. Oh, they're on the table here. And cut them out by hand. Let me show you. I should probably do that just to show you. I don't have the hands that Phil obviously has. And so when I go to use my shears, I put them in my vise. And it allows you to come in and cut shapes pretty quickly. And you'll see on the lathe that we don't need to have them be perfect. Could be a little bit more perfect than this. I didn't draw my line. So. There we go. So anyway, get yourself a decent pair of shears like this for about $30. You're going to be a lot happier than spending the money for a circle cutter. Unless you can stumble across one. Am I forgetting things? I feel like I'm rushing, and I'm not sure why I'm rushing. Except that time-wise, at the end of the day, fine. When it comes to spinning metal, basically what you need to do is kind of guesstimate how much metal you're going to need and what diameter. And I wish I could tell you, I know there's a formula for raising, where you take the height and the diameter and and it's like that. The problem with metal spinning is it stretches. And if we took the time to cut one of these open, the 24 gauge down here, it's probably 25 gauge up here. So it's a stretching process. And you're going to be pretty amazed at how elastic and how far it does stretch. So it's a matter of practice. So I always usually take a scrap piece of copper and guesstimate, spin it up, know how much I needed to trim off or know how short I was, and cut another circle. And it also depends on what your skill level is in the forming it and how much you're going to stretch it. Because there are people that can stretch up almost vertical forms and really not lose much of it because they actually pack it when they're pushing it back. So. Okay, so I'm going to go ahead and put my disc that I've guesstimated on in, clamp it. One of the things that they do in industry is that they turn the machine on, and while it's running, they loosen up the tailstock and they center it with the disc while it's loose. I've chosen never to do that. There was a split in the face shield at RIT that reminded me that probably isn't very smart. So what I do is I put it in and I eyeball it, and to me that's centered well enough. It's not going to affect how things go, and I'm going to do a little bit of trimming here. But what I want to do is tighten this down, lock this so it's not going to move, and now what I need to do is get my tool rest in a decent position to work off of. And then the next thing that you need to do is use some kind of lubricant, because if you take a dry steel tool onto a spinning piece of metal, they're going to stick to each other. So I started using tallow, which is animal fat, and I think I've got some recipes on different spinners on that. I've kind of gone to using bearing grease. And I know it's just fossilized dead animals, but for some reason it doesn't smell as bad in the studio. It's still dirty and greasy. But what you're going to want to do is just take a little smidgen of it and put it on the piece of metal itself. And usually with beginning students is they use way too much of it and they coat themselves and they coat the wall. It doesn't take much, but you do need to have something to break that surface a little bit. And then I'm going to try some of my new tools here.
Then which side did you put the bearing grease?
On the side I'm going to be working on. The side that doesn't end up being pressed down onto the form. And so this is something, before I turn it on and get going, that everybody maybe might want to come and see. But your fulcrum pin needs to be slightly behind where you're working. So basically your fulcrum pin needs to be behind your disc by about the thickness of the tool. And the big mistake people make is as they get the metal to move up, they don't change their fulcrum pin, and the next thing you know is they're stabbing their piece. So I think in the handout I gave you, there's really good examples of how you move the fulcrum pin on down and on your way of working. The other mistake people make is that they think that you want to be working here. And if you think of this disc as a clock face, we're going to be working at about 7 o'clock. Okay. Most people try to spin metal at 9. And you poke holes in your metal, you stretch it, you tear it. So you want to come in and you work down below. And I'm not forming the metal with the point, I'm forming the metal with this tip here, this nice rounded finish. Yep. And I'm going to come in and first thing I'm going to do is seat the metal onto the lathe. And you'll see that in a minute. And once I do that, which is just a matter of pushing the tool like this, and someone asked about why I got longer handles. Helps me out. I'm going to seat that on there because right now there's a really good chance that this disc, there's a chance that this disc could come off because all it is clamped like this. The minute you push the metal over and it does this, it's never coming off. So that's the first thing you want to do is seat your metal onto there. Once you've done that, then you begin the process, which is very rhythmic and very methodical, of working down and back up, down and back up. And one of the things that you need to do is as you get to the outside, you need to lighten up. If you push too hard, you get wrinkles. If you don't seat your metal down right in the beginning, you end up tearing a hole in the bottom of your disc. So working on the new lathe, I was able to do pretty much one of everything until I got a feel for it. So we'll see what we do here. And I'm just going to begin the process. If anybody's really worried, right there might not be a good spot, and right where I'm standing might not be a good spot, but everything will be fine. Tool rest is tight. I've done a full spin. Nothing's going to come in contact. I'm going to go ahead and turn it on. In the way of speeds, this is probably a little slow. I'm going to run it probably around 1600 RPMs. If I'm working on a 20-inch disc, I might be running it at 600 RPMs because it's just like the bigger buffs you have, the faster they rotate. Same thing happening here. So you're just going to need to play around with that a little bit. My old lathe had 4 speeds and I didn't have the opportunity, and it's been really fun getting a chance to have this. So I have just now seated the metal down on there. And my problem when I first started learning how to spin metal is like, well, that's a cool shape. And I took it as far as I could get. But I'm going to go ahead and see if I can draw this whole piece of metal up without having to anneal it. I might have to anneal it.
Is it annealed?
This is annealed down. It's dead soft. I buy mine dead soft, so I don't have to do the first annealing. But see what I mean by the seat? So once you've got it seated down there, you have no risk of it coming off anymore, and I can begin the forming process here. Got everything tight. Let's see. Can I move my tool? Can I work it all the way out? Back in.
Are you pushing on the metal when you work it back down
A
towards
little
the
bit.
center?
Yeah, if you do it right, when you push back in, you keep the thickness. If you're always just drawing the metal out, you're going to thin it and you're going to tear it out. And I'm already almost at the point of needing to move my fulcrum. And the other thing that I'm needing to do, and I think the diagram shows really well, is it's not like angle raising. I'm not going up in angles. I want to keep this outside edge perpendicular to the lathe. That's what gives it structural support. And if you don't realize that, you're going to have all kinds of trouble spinning metal. If you understand that, and I think that handout, is there? She did it backwards for me. This is perfect in explaining what we're talking about here. So it really goes against everything you learn about raising metal, especially if you don't do crimp raising and you do angle raising. So I'm pretty much ready at this point to move my fulcrum or move my tool rest down. And I always want to keep that tool rest just about the thickness of my tool behind, so that I'm right there working it and I'm not going to be poking it. And this is a very good piece of metal, so this is smaller. So now I've got to do some seating here. And I'm going to need to anneal this. Sometimes when you just get going and you go at it in a hurry, you have much better luck. Can you see how it's starting to wobble a little bit right here?
Yeah.
That's when you start to do bottom tear out. Did you hear that pop? Yep. No, it wasn't cracked yet. Let me see how. Let's see where it's at. It's hot. The other thing that you can do to relieve some of the tension on it, and I should have stopped when I saw it, is to go back in and trim off the edge. Really, all the tension in the metal from spinning is on this outside edge. And if you trim it away, all of a sudden you'll get a lot more passing.
How would you trim it?
That's all. Let me put another disc on and we'll give it a shot and see if I can do any better this time. So I think I kind of it's one.
How many times usually do you anneal it before you get it completely formed onto there?
2, 3. These guys, when I made them go up yesterday, I was finally getting the hang of it. I don't have any annealings in the knees. I just, you know, when that sometimes things flow out of your hands.
Yeah.
But normally a form like this would probably have 3 annealings to it.
And how many times do you think you move that needle? About that many times?
Yeah, you basically just follow the fulcrum right up the piece.
I just didn't know if it would maybe be good just every time you had to move it, just anneal it.
Stop and anneal it. Well, I think Phil's point this morning was really good. If you over anneal things, you're just opening up the pores of the metal, and so you really want to pack it. And that's the other thing about spinning sterling silver is sterling doesn't like to be stretched, it likes to be compressed. So if I were going to end up with a spun form like this out of silver, I would make 2 gradual patterns that were shallower, and I would be able to spin them up, press the silver right down onto that wooden form, and then take it off and do the next one. And I have different shapes in my studio on my bigger lathe so that I can go a shallow, a more deep one, and then a real tall one. And that way, once the metal gets down onto the wood, you are compressing it. You're just not always stretching it over air.
Have you ever had the problem of getting the metal off the
Yeah.
A lot of times what I'll do is just take my torch, heat the metal just a little bit, and then I use a wooden tool from the back side of it and pop it off. And I'll probably get this one stuck on and show you that. There are ways to get it off. But heat sometimes will cause the metal to expand a little bit and cause it to pop off.
Okay.
Where I've had problems with things getting stuck on there is pewter. Pewter's so soft it just sucks onto things. Okay, let's see if I can have more success this time. This is a very, I don't know why I set myself up for one of the most difficult forms to do.
Yeah, this is the one that just cracked.
Oh, I'm way in the center here. That one's not. Yeah, can you see where it's split? And part of that is I probably didn't have it seated down onto the wood form enough. Yeah, it does. And when I used to do production in a lot of these pieces, what I would do is cut all my circles, check the size of my tailstock, draw that circle on it so that I could just line it up right on here. And you could put one right after another on.
Could you do more than one at a
What?
time? Could you put more than one on at a time?
Disc at a time. I found that the one behind wrinkles, the one here wrinkles. But what you can do is spin up one form and then spin another one up on top of it, and another one on top of it, which has some possibilities. And the other thing is I was going to talk about hopefully is you can spin something other than a circle. Maybe it's off.
It's not you.
That's better. And I also might be running this at a too slow a speed too. Can you see how it just pretty much pushes it right down onto that surface? One of the hardest things about teaching is that you really do lose your whole movement, kind of talk and demo at the same time. And I found it's like glass blowing, you really do need to just keep that rhythm going. And you can see how that edge kicked back? That's telling me in the way the sound of the metal, I can tell it's time to trim this. So I'm going to go ahead and put my glove on. And this is a terrible sound. You guys might want to plug your ears. I remember when I was in Madison, Wisconsin, the person in the studio next door said, "It sounds like you're killing animals next door." I really forgotten. So I'm gonna put in. And it keeps catching, which means something's not right. I don't know. And I usually always wear headphones. I don't have them on now. And after you do that, especially with sterling silver, you want to take a file and you want to get the burr off. And you never want to use a file without a handle on it. You don't want to use a file without a handle anyway, but this is it. And you just come in. Take that burr off. If you don't with sterling, it'll just crack right on down that seam. We'll see if I have any more life in this. Oh, good. There's a little bit more life here.
So again, Lynn, more pressure on the downward stroke.
There's more pressure when you're close to the wooden form,
Yes.
and a lot less pressure when you get out because you've got nothing supporting the metal behind you there. And I have a little ripple. Can you hear that? And one of the ways that you correct that is you can come in, put your tool, and I should shut it off.
Right, I was just thinking.
And that's what I made that one forming tool for that kind of bows here. Put it right back there, and you can come in and you can squeeze the two of them, and that takes out your wrinkles.
You put it on the back side.
Yep. There's not much of a wrinkle there, but, and it also probably tells me it's time to trim that edge a little bit. Straighten it out.
You were saying you would take the tension off of it by trimming the outer edge? Is that what you're doing with the file when you deburred it?
No, that's what I was doing with my cutting tool here, this guy. Coming in now. Getting low and on the video here. This is just to take the burr off from the trimming. Kind of like when you use a ruler saw, you want to get back in with the file to get the burr off. Same thing here. And I'm going to go back in. And there's a very good chance that I don't have this thing totally seated against the wood, so I'm going to take the flat side of this tool. And I'm going to burnish it and make it sit nice and smooth. Just like with hammers, if your tools are polished, you're going to polish your metal. If they're a mess, they're going to leave the surface a mess, which can be nice. And now I think I can continue. Really asking a lot of this piece of copper.
Oh, but you're so close now.
I know. Okay, now I'm at a point where I have to think about my tool rest again.
Oh, just think all the hammering you'd have to do to get to this point.
That's right.
No kidding.
Well, it was really interesting for me when in graduate school because Hans Christensen was teaching there and so was Gary Griffin, and Hans was totally anti-spinning, but with now a little bit of history and understanding what the Industrial Revolution did to the craftsperson, I can see why he had that attitude. But in this day and age, to have the ability to form something this quickly is pretty worthwhile to consider. And I look at it as like throwing on a potter's wheel. You know, what's the difference? It's hand-built or it's thrown. Oh, I got the wrong side. that's why that's doing that, since I'm not familiar with that tool rest.
Can you, like solder to the metal, like you married metal and then spin?
I haven't done married metals, but I've used Phil Baldwin's Mokame. Spins beautifully. So I don't know if I would sweat solder things together or do soldering, but if you were going to fuse different metals together, they spin beautifully. Okay, so at this point what I did is I went in and trimmed this edge because the last thing I want to do is to push it down onto the wooden form. If I have to go in and trim it then, I'm going to cut into the wooden form. So can you see how I've just got this little kicked up edge here? Unfortunately, I always like that kicked up little edge, and so usually I leave it, but I'm going to put this one down for you. But if you really want the life of your chucks to last, trim them before you push the last little part down. The wood.
Oh,
If I push it all the way down and have to then trim it, I'm going to cut ridges into the wooden form.
yeah.
So it's just a matter. You can reuse this form. I have some that I've probably gotten 300 formings out of before they started to break down.
Now again, what was the reason this was on crack?
I don't think I had it seated onto the wood. So the only thing that was really, all the forming was all happening right where that ring was. It's really common blowing out holes in the bottom of them. Then you learn to use those for the lids and you cut the hole out. So now I'm going to come in with my burnishing tool. And first off, I'm going to come in and lock that back edge down. Okay, and then I'm going to come in with my smooth tool, and I'm going to start to burnish this out. This is also about the time that you press it so hard down onto the wood form it doesn't want to come off. So there is a certain amount of, you might want to go back in with some sandpaper to take out the rest of it. And I certainly would have better luck getting out these tooling lines if I took it off and annealed it. It's metal, this would probably really stretch to the max. Let me shut it off. We'll see about whether or not it's going to want to come off. If it doesn't want to come off, what I do is I back up the tool rest, the tailstock, just enough so it's loose. I take my fulcrum pin and put it in a strategic spot, and I come in from this side and pry it off this. And if you're really worried about your edge, you might use a piece of wood. I don't know why we're not having. So, we can keep going. Some things that I like to do is spin up the forms, cut the interior spaces out of them. I really like to make things that have lids that fit inside them. So I wanted, if we had time to talk about that, is thinking about making an outside form and then a lid that either fits on the inside or the outside of it. And normally what I'll do is say I wanted to now have a lid for this. What I would do is I would make my wooden form first and I would spin up a prototype, and then I would take some measurements off of this, and then I would make a wooden form, taking into consideration the thickness of my metal here. And I would then turn a wood form that was just that size that would fit onto this. I've never had really good luck making the wooden patterns first and then sticking them together. I've always needed to make a prototype for that. We can spin one of those up. One of the protection pieces I did for a while that I probably should have pursued more of was a shape similar to this with a four-sided piece. And then I've started making forms that are a little bit more organic, so oval shapes, or cutting out different shapes with a jeweler's saw and then putting them on the lid, and they really do react and stretch differently. So I do want to spin up a square piece for you. It makes a little bit of noise. Okay, where's my tool rest? And probably when you're first learning how to spin metal, you probably don't want to have to do a square first. Because I always remember my summer school teacher, Paul Tarantino, that used to teach at Buffalo State. He had gotten a chance to work in industry for a while and was an excellent spinner. And he had a wooden form that had a hole in it, and I was nervous about working on it. He said, "I will give you everything I own if you can get." think I have it seated down really well. That was my original mistake. And you can hear it when I get out to that outside edge. And I should stop along the way for you to see what it looks like in process. So you've got just a beautiful, think of Roger Horner's candlestick.
Just
where
like,
you
just like that.
Stop there. Well, that was the other thing is when,
Just the edges on the square ones, because now you can't pull them off.
right.
Or you file them up a little bit.
I take them off the lathe and cut them or shape them any way I
Okay.
want. Yeah. I probably wouldn't try to cut them with a cutting tool while they're on the lathe.
No.
Can you work with an
Um,
asymmetrical shape on the lathe?
Pardon me?
Can you work with an asymmetrical shape to start with? So say you
Of the
wanted-
form
Yeah,
or the metal?
well, say you put you wanted a form when it was done, so it kind of scooped down and around. Could you put a piece of metal on there?
That's what I was saying. You can take a piece of metal and cut it out with a jeweler's saw,
And then,
and you'll get different stretching or wrinkling, and you'll see this starts to really sag into here, so it's drawing metal down. It's just similar to the hydraulic press, if you've done hydraulic press work before. The one thing I found fascinating is you could make one wooden form, and you could end up with 30 different shapes because you're working over air. So I could take this and come in with my tool from the back side and kick this and have it come curl down and around. So I did a lot of work over air, which is a term that just means basically you got a wooden form and you're not pressing it all the way down. You got to seat it down on here so it doesn't break loose, but after that you can work over air. They just usually in industry, they only thought of it as they want each one of these to be exactly the same. And so that's where the versatility comes from, is if you're willing to quote unquote work over air. Stop here, you know.
so you can take that top and roll it back.
Uh-huh.
Lynn?
How much strength?
Are you putting into it?
Not much at all here. On the larger scale, a lot.
But not much on the scale.
Yeah, there are just some things that I really probably haven't talked about, but when you go to use it, it's posture. It's just like I remember watching Fred Fenster teach a forging demonstration, how you stand, how you hold the tools. And basically you need to be square, you need to be at the right height. And for me, this worked perfect because he knew, I mean the lathe that actually I bought from him, he built it so that the whole thing is like 3 inches shorter than most of the wood turning lathes because he knew being a spinner I need to be up top more than down low. So that's some of it. And then the other thing is just putting it flat down. You got your support right here. So my left hand is really doing most of the weight pulling down and my right hand is doing all the fine tuning.
Because you're spinning metal, you need to go down into it.
Yeah, I'm working at about 7 o'clock off the clock face. Is that about right? This tool rest might be a little low.
But if you were doing wood, you might be even with it.
Yeah, with wood you want to be
could have it higher
right
up.
on center or slightly above. So it's totally different. It's interesting because I'm not that fond of turning wood, and the woodworkers, when they see and do the metal, it's so foreign to them, working down underneath and on the bottom on that. And turning wood is kind of that way for me on that end of it. But yeah, I could go back in and roll this edge back over. And in industry, what they'll do a lot of times is spin up a form part way, take it off, put another form on, and then turn this form around the other way and spin it back up so that you'll get a donut shape, basically, those kind of things. They were actually very creative with the spinning lathe at the turn of the century, and in the 30s and 40s, hydraulic press work started to come into play. And that's why there isn't much spinning done at all in this country anymore. Because really, it's not worth their while to do a spun thing. I mean, maybe up to 30 or 40. After that, you might as well think about making a hydraulic press and pressing these forms. You know, but then at that point, you've got to be willing to make hundreds of something.
Hasn't Helen Shirk used spun
Mm-hmm.
vessel, jumping off point for her vessel?
Absolutely.
And I think Stakely did too at an earlier time. I don't know if he's still doing
Yeah.
it.
Yeah, I know that she said when she was raising her child when he was real young, she didn't have the time to raise things, so she started looking into finding found things and going to a spinning shop and buying them already made as good. For me, I kind of like the process of the forming of it, and my ideas develop while I'm working on them. I enjoy it too. Okay, I'm going to go ahead and see how much farther I can push this so that you can see what happens when you get to the point. When you get to the point of where the metal starts to wrinkle really radically because of the square We're not quite there yet. But you notice that I'm still keeping that metal edge, even though it's just 4 points now, perpendicular to the whole lathe here. And that wobble is now where I'm working over that outside edge. And now I'm going to start getting some wrinkles because I'm out to that edge. It actually was pretty amazing the way that it actually started. So at this point, if you didn't want these wrinkles in here, you could anneal it, put it back on this form, and hammer it out. Slightly off. More stuff. What do I need to do? Oh, I wanted to spin something up so I could cut a center out for you guys. Because for me, being able to do that with the vessel form, cutting open the tops and being able to look down into them was really important. That way. It's really a wonderful device in the way of a tool. Sorry, I didn't want to do that yet. My old lathe, I had to use face plates on everything, and it really took up a lot more time. And I really started paying attention when I bought this new lathe and started working with it, is that I would say that I saved at least 40% of my time, just because of the quick change of things and the ability to change the tooling around so quickly. Do you guys want me to turn more wood, or should I just use one of the forms that I already have? We're more interested in that part.
Yeah.
All I have to do is find it. I passed one around that had a wooden tailstock. Oh, there it is right there. Thank you very much. We'll use that guy. He's still Yeah, and I've actually been toying with the idea of trying to convince Aramon into letting me come down and do a 2-week workshop. The first week I have Stoney Lamar, who's a wonderful wood turner, teach all of us how to turn wood. The second week we spin metal, so it's something that's possibly in the wood. Because really to have somebody that's an excellent wood turner would really make things come alive. And then being able to combine wood and metal.
Can you turn metal on that?
You can. Like I said, there's a fellow up in Canada who's free-forming with his woodworking tools, cutting brass and stuff like that. It's not what you think of as a traditional metal lathe like our South Bend back there, that it has all the gears and dials. So once again, it's freehand. And if you feel comfortable with the freehand end of it, you certainly can. I mean, I was pretty impressed with it, with what he was doing. Because once again, it wouldn't have been something I would have thought of. If you were going to make a platter form and you wanted a nice flat bottom on it, you would want your tailstock to be as big as that flat spot on the platter. So always keep that in mind when you're thinking about the tailstock, is really that's going to establish your base.
How then do you get to the hard place? I noticed some of those things actually curve on the
I have tailstocks that have, yeah. Well, that I just put in the dapping block afterwards and make that happen.
I was thinking this one. Yeah.
I think I put that in the dapping block too, but you can make tailstocks
I see.
that are curved. So that the first thing you do is press your metal on there. Does that make sense?
Yeah.
What I found with them is that you never can really quite get them centered. They don't have a center when they're round the bottom. So if you're doing silver and you got to take it off a lot and anneal it, you never quite get it back on square. So most of the time I do a flat bottom and then I bouge it out afterwards. Same thing with the bell here. I mean, that was a flat bottom, then it popped up in the dapping block afterwards. So that's why I see the lathe as just being the one step at the beginning of all the other things you do. Okay, I'm gonna go ahead and spin this guy up, and then I'll cut part of the bottom out of it. And I probably actually could have used a bigger piece of metal, but. Tool. It was a wonderful little setup they had, but I'm not used to it yet. Even with this shallow bottom, I'm going to seed it. And I'm probably stretching it a little bit when I should be moving the tool rest down a little bit. And that's one thing with this tool rest is the spacing between the fulcrums is a little big. So that's why I'm having to move the tool rest, whereas my other lathe, I can really just move the pins down. It'd be really fun to take one of these and cut them open and see how much thinner they really are. Oops. If you ever feel your tool being stuck down in there, you don't have enough lubricant on it. It's a feeling of being sucked into a black hole. Off the lathe, I have no way of really putting it back on there. So what you want to do is finish the forms exactly the way you want. Truing up that edge. I'm going to leave a nice little lip here. Burnishing tool, smooth out, and this is wobbling a little bit, and I can't tell. I think I might have pulled the chuck loose. In industry, and I always stayed away from it because it was so industrial, but in industry, like a mixing bowl, how they roll the edge back on itself, that's one of the things that you can do. Pins are awful tight. Loosen up. That's what he'll tell me. They'll loosen up. And one of the ways that you can roll the edge back over is you come in from the other side. And this metal might be pretty work hardened. So do it completely. Can you see how I'm pulling? Asking a lot of it at this point without annealing it. But can you see how the edge is starting to roll back over? And now I need to true it up. But I always thought things looked like mixing bowls, and I was already getting enough flack for working on a lathe that I certainly stayed away from that because dealing with that thin edge. But anyway, I'm going to trim this a little bit, and then I think we can roll it a little bit farther. Perpendicular to the surface so that you know when it was out straight I was trimming it like this. Now you want to come over. This copper has been very good to me today, and so you're not needing to be annealed. And then when it gets to that point, then you want to come from the other side of it. I can move this roller out. So work hard with this one. I think you get the idea. Forming and rolling over that edge. And I remember Paul saying that in industry they have to go back in and they actually with magnifying glasses go back in and make sure that there's no opening here, that food can get tucked down underneath there. But that's a nice way of kind of handling an edge. It's a little flat, not perfectly round, but considering I didn't anneal it. And then I still got an opening.
Yeah, I press my boards, but that is not, I press my boards over,
Hydraulic presses, they have their, they definitely have their purposes. I just remember being in junior high school and I had a choice to take home ec or industrial design. It was the first year at the Bellevue School District that they let girls make that choice, and I worked on all kinds of lathes that year, and I just fell in love with them. And so to find an opportunity to use it in metalsmithing was really great in graduate school.
the problem what I have on my press is that you don't have the middle. If you want to have the edge, and you want to make a goblet, and you want to put it on a stem, you are never in the middle.
Oh.
Yeah. That's why
You
I'm
got
so
a center
into.
part
The
here.
press,
Yes.
you can't get in.
You make your, if you've got a
If I have
half-inch,
this hole in the middle of the press, it pops. If I have the fine silver
mark,
and mark, and I did everything to find the middle.
Yeah.
It's not possible.
when I've done goblets that have stems on them, is you just make your tailstock the same diameter that your stem is, and you'll have a line there that's left,
Yes.
and you just line it right up there to solder it.
Make your tailstock the same diameter.
As a stem.
The stem,
Down.
tubing usually it is, could be solid.
Tubing in it. That's what I did. Yeah, easy.
You know, I wish I could answer the question about how hard I am doing this, but it's kind of like when you teach polishing. Like, how do you explain to somebody how hard they need to be pushing on the buttons? It's just something that you just got to get on and do. See now this rolled edge
Yeah.
isn't necessarily great for trimming. Thought. So the pulls the tool down. I just need to stay closer than I normally do. Let's say what I want to do here now is that I want to cut this off and have a rim that maybe I can stick onto something. This is where having the ability to turn your speedway down is really good so that I don't end up catching it when it cuts through the cutting tool. This cutting tool that has a sharper point on it, I can actually use it to turn that center out. So I'm going to come in with that point. Oh. But anyway, that's how you would cut a center out. And my other tool, one that Gary made for me that's too big for this blade, is perfect for that, because basically I've got something that looks like it's a kind of separating tool that goes in and cuts those off really well. What else did I need to show you in all the possibilities? I should probably try spinning up a piece of brass, because you'll see that it's quite a bit different. And normally what I do with brass is that I go with a little bit lighter gauge. This happens to be about the same gauge, so it's going to take a little bit more effort. Nickel silver is also that way. It's really a bear to spin. And then one time I just muscled through it, got the piece up into a form similar to that, put it on the workbench, went to do something else, and about 3 minutes into it I heard it go pop, 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 and it cracked open like an egg. There was so much stress involved in it. And phos copper is also that way. But anyway, each metal is a little bit different. It's like learning how to solder each metal. You just need to kind of learn its temperament. But the brass usually doesn't form as easily, and I have to anneal it a little more often. It has a tendency to need more lubricant. It drags on the tool a little bit more, as you saw it just catching on me there. And I would say that I'm probably pushing twice as hard as when I'm working with copper. And sterling silver is somewhere in between brass and copper when it comes to forming. I used to spin silver for people because it was like, oh wow, $500 versus somebody else's silver, this will be fun. Gotten to the point where it's really not a whole lot different than any of the other metals. But in the beginning it was quite a challenge. And once again that had to do with it needs to be compressed on a regular basis. And then also brass turns differently. It's a much kinder tool for turning. It's harder, so it cuts better than copper does. Did you hear that chattering and all of a sudden the chatter went away?
Yeah.
And I'm finally true. And so it's nice not to have to stop the lathe and look to see if you're there yet. Is to learn to feel that.
Is that actually smoking?
Uh-huh.
Is it burning the wood or?
It's burning the oil that's on the lathe. So it's a couple hundred degrees. That's why I also wear a glove, because a lot of times the chips will come off. Here I am saying that this is going to need an anneal. Oh, we just don't use torches around here. But that was the thing for me, is not having, with raising. I mean, I enjoy the process of raising, but getting out of school and thinking about trying to offer hollowware that's hand raised seemed impossible. And then if I'd ever known that time would be so short, I definitely would have done it for that reason as well. It's getting there. I could make caps for the plumbing industry. Requests? You want to give it a try today? People go home, or they can go home and you can. Did it help? He's done some spinning before, so it's always good to hear somebody that's done some, and then maybe some of you guys have too. But in the way of answering questions.
Did you try gold?
I haven't tried gold. I bought a couple of gold coins and decided I'd wait and see what Phil had to say about gold alloying before I alloyed them to spin.
Oh, but fine, so.
Oh, that's butter. If If you're gonna spin fine silver, you should use a wooden dowel instead of a steel tool, because you'll just spin it out and stretch it and tear it so quickly.
But wouldn't that depress it?
Yeah, forming tool. This end.
Oh, that, oh, okay.
Same thing with pewter. Gosh, I started working with pewter and I was just going crazy. And then I went to Madison. Fred wasn't there that year, but Eleanor said, call him. And I called him and he said, you got to use the end of a wooden baseball bat. And I was like, oh,
Sure.
you know, something soft. And that's what I found with fine silver when I have done. I mean, for me, I like the preference of sterling because it stays, it's hard when you're done. But fine silver, you're just going to want to use the end of a wooden tool.
You ever shape rod?
Pardon me?
You ever shape rod like for a stem of a goblet?
That's one thing actually I'm thinking about pursuing, especially now with this kind of chuck on here, is that you could shape rod, but what I really want to do is tubing. If you know the old brass lamps that are made out of tubing, they're put on the lathe, spinning lathe, and tooled from underneath to have the undulations of the ins and outs. So you're thinking more of removing material? Yeah, you can remove material. I mean, that's what I'm doing here on a rod. You just need to figure out a way to secure it so that this end, you know what I'm saying? You almost need one of these on this end so that you've got two chucks that rotate to hold it in place. But it finally dawned on me that that's how those candlesticks are made, is it's tubing they put on a lathe and compressed and shaped.
I hadn't thought about tubing.
Yeah. Oh, I love working with tubing.
Lynn, there's this line that you're doing a bracelet for. How do you then part off the base?
Cut it, trim it right off the bottom just like I did. So you've got the loss of that base, but then you can take that disc and do something else with it. Yeah, you lose the ends on both of them. But she designed that so that it was a hollow constructed bracelet and it came up pretty quickly. And the way that it came apart, it was designed. You know, you've got a day's worth of work to make the die, but then you've got the ability to make multiple parts pretty quickly. Because that's the one thing I didn't talk about today was the fact that you have the ability to do what are called breakdown chucks, because normally you can only go up within 5 degrees of vertical. And that's the other thing that might be happening is maybe the wood's vertical. That'll keep it, you've got to have that 5% drag to get the thing off. So if you want something that comes back in on itself, you can make breakdown chucks like I've got in there. What I've started doing is just making tops and bottoms and brazing them together, which is basically what I've done here with this pot. This pot has a seam here, has a seam here, has a seam here, and then the copper tubing on top. Because what I found is by the time you go around to making the breakdown chucks, unless you make them out of steel, they really don't last that long. So I enjoy the process of soldering things together. The hardest part about soldering things together, hollow forms, is to get them to fit together really well. They fit together really well when they come off the lathe because they're symmetrical. So you don't have that tedious work of trying to make things fit together. You have the ability to pull them off the lathe, clean them. I usually anneal them before I solder them together so they don't shift around because they're usually terribly work hard.
Right.
And then when you solder them, they just sit down.
And what kind of solder?
I'm using a phos copper brazing rod.
Okay.
So the problem with it is it's brittle. You can't work it afterwards. And then there's only one temperature. So you get very good at figuring out ways to keep things from falling apart while you're putting it together.
Oh.
But it matches well enough, whereas sterling, I missed the part that Phil was talking today about somehow getting your solder copper color. Wasn't he talking about that today?
Powder, silver, and the jars. Basically, what's happening is the protective bond where you're lowering the level
Of the copper
in the
to
vicinity
stick
of
them
the
together.
copper.
And the silver goes right in and you don't see it, and it's just fine.
The other solution is a TIG welder. The phos copper brazing rod I like as long as I'm not having to go back in and work the pieces afterwards. And then if they've gotten damaged, because I've gotten pieces back from San Francisco that have needed to be repaired, it's a little problem with the phos copper. Silver usually can just bend it in. And the other one that I have is in the beginnings of a collaborative piece. A wood turner has this wonderful, incredible translucent bowl that fits in here. But anyway, this was, someone asked about shapes. This was a shape that I cut out and then put on the lathe and formed it. And so you do get some decent things happening with the different shapes that are there. It's a fumigated ammonia patina. Same old, same old.
Did you have to seal patina on that?
Yep.
Okay.
Yeah. I once
Lacquer?
again those doggone woodworkers. Carnauba wax. 100% carnauba wax. It's wonderful. I used to lacquer everything. So it's carnauba wax. It's got, so it takes longer, 6 or 7 coats if you really want it nice. I do 3 and call it good. Yeah. And someone asked earlier about patinas with fill. I guess I have a pet peeve because people think you need to wax or lacquer them to keep them on the surface. If they're applied correctly, they should not come off. What the patina needs is it needs to be sealed from the environment so dirty hands, oxidation, oils don't get to it. And that's all the wax and lacquer is. It also helps bring up the depth that's there. But there was so much work in the early 80s where people were patinaing things and not doing it correctly and stuff was flaking off. And people would say that it's not very permanent. And what I found is that I could not only with a rawhide mallet and a wooden form is knock out the dents of pieces that were patinaed that didn't even need to be repatinaed. So that tells me that they're pretty strong if they're done right.
You mean follow the instructions?
Clean, done it right. Of the years that I was doing production work, I would say I got faster at spinning, faster at soldering and fabrication. My finish work never got any faster. It was like David said about polishing. There's just that part of tedium that finish work is finish work. Anything else? Something specific? Did this help in the way of possibilities for people? So I've been for years wanting people to work on lathes and do this kind of work because it's kind of, there are a few people out there, but not many.
The only person I've ever seen do it was at Somerville, Elliot Pujol, did some spinning. But you're the person I've seen do it.
There's some things about it that can be unnerving. Like I said, loosening up that center disc and centering it that way, don't. Just clamp it on there and eyeball it and true it up. And the noise, there just are some people that aren't interested in the process, but on this scale and making jewelry scale pieces, I think of Sandy Enderlein's work, and I think, gosh, to make those, if she could if she could spin some forms instead of having to raise them, what else? Then you'd have the feeling that you had the time to really take that form and alter it and shape it and do things with it, if you hadn't spent days getting that form there. And she and I talked a little bit about that.
Bill Seeley mentioned a workshop we did a couple of weekends ago about raising titanium, and he showed us one of the bones available. There are very few, I guess, that anybody even knows where they are anymore, but it was incredible because it looks like a brown patina, or glazed pot, but the inside, I guess it's the crystalline structure, changes and it gives it this textured surface, and the lip comes out, and it's just phenomenal. It's just amazing what it
So
looks like.
titanium needs to be worked hot. Be done on the lathe. I think it has to be worked hot.
I don't remember
It
exactly,
needs
but
to
he
be
showed us
red hot for forming. Because I've watched Boeing. Boeing extruded some tubing into these wonderful goblet shapes, but they were some type of exhaust system for their airplanes. And they had a steel chuck, and it was done on a lathe, and they had 2 torches coming at it while the person was working, and it was red hot. So it was like blacksmithing.
He didn't mention that, but
You didn't talk about that? Yeah. Yeah, because it's a remarkable material. It's lightweight for aircraft. They've done a lot of experimenting here.
Well, basically, if we want to do it, we have to come here.
For the spin metal? Yeah. You can.
are you going to get it
Or buy,
I'm,
buy one of these.
yeah. Well,
There you go.
hey, I tell you, my first lathe that I bought, it's probably the best investment I've ever made because when I bought my new one, I turned around and I sold my old lathe for 4 times what I paid for it originally. And I used it for 15 years. So it was like, well, that seems better than the So my feeling about tools is if you buy good quality ones, they'll last forever and the value of them will never go down.
As soon as you get fine woodworker excited about the possibilities of combining your art.
How did I?
I said that seems like that would be a good thing to do to start off with.
Yeah, I've been real fortunate that the woodworkers have really adopted me in a lot of their shows because I am an extension of the lathe turned objects. And I've been fortunate enough that a lot of their collectors have started buying some of my work because they can get the sense of the process involved in it.
The $1,200 that this lathe costs, is that Canadian or?
It's American.
US? That's US.
It is not in here, in the price.
No, this
No,
thing is
this is
his
a brand new
prototype that he shipped to me, and he promised me that I would send it back in one piece to him, and that,
He said
I
we're
think
gonna do
that's
that
an
again.
act of faith right there,
Yeah.
which is to your credit.
they're a remarkable company. I don't mean to be a sales pitch here for you, because I don't get anything out of it, except there might be people that are working on lathes out there, but he's probably in his mid-60s, was a machinist, started this business. His son is about my age, he's 40, very much computer oriented, so his son does the drive, the computerized motor mechanisms, all of that, and he does the machine part, and they're really a wonderful team because he doesn't have the computer skills, but his son does, and that's the advantage here, but someone that doesn't have the old machinist skills, it's just an ideal working situation, and it's family run. The wife runs the office, and the daughter is in the shipping area. But their business has grown remarkably.
What's he gonna call this? Is it just metal lathe or?
This is his smaller, it's their one-way lathe. I think it's got a 6-inch swing on it, which what it means is from the center here down, that's what's called the swing on it.
It's basically a wood lathe.
It's basically a wood lathe, yep. The reason why I was so impressed with it is when I was up in Canada 2 years ago, they had a workshop, amazing workshop. There were 100 people that came to it, and there were 20 of us that they called facilitators instead of being instructors. And it was up on Lake Emma, incredible lake, about 100 miles north of Saskatoon. And it used to be a painting facility where people would come from Saskatoon, from the university there, and go up and paint in the summertime. And had this, these cabins, they fed us, they had this big, huge central room that they brought in a power generator, and they set up a woodworking facility that had about 16 lathes, 2 or 3 table saws. It was remarkable to stand there and watch them unload all this equipment, wire in this whole studio within 24 hours, and then we worked for a week collaboratively. We all showed slides the first night of our work, and then it was on your mark, get set, go, and then people worked for the next 6 or 7 days. And then at the end of that, we loaded up all the equipment back into the truck. I helped on that end of it, load it back up. Stood there watching them unload it in amazement. Swept the floors, put down chairs, and we auctioned off all the work, collaborative work that was there, and raised enough money to have it happen again this summer. And I'm thrilled that they've asked me to come back.
When is that?
It's in the end of July. So anyway, they asked me to come because they wanted to start expanding the idea of metal spinning involved in all of this. And so they had me out back under the shed on sand, and there was the full-size lathe, and I was spinning 18 and 20-inch discs, and that lathe didn't move. It wasn't bolted down, didn't walk. It's so solid. The whole concept of using the tube, for me, is intriguing because coming from aircraft country with Boeing, and knowing and understanding the structural strength of it. My big lathe, the tube is mounted underneath. The reason why this one's offset is that he's hoping that will enable people in wheelchairs to work off of this lathe, which I thought was also very interesting for him to think about that in those ways. So anyway, it's just a fine piece of equipment, and like I said, because it shuts off quickly and because of the variable speed, it's so much safer. The noise level, you've worked with enough lathes, what do you think?
Well, I think it's
Working.
a magnificent piece of equipment, really.
Yeah, and he says they're expensive. You can go buy an Australian one for about $400, but you're going to want to throw it in the garbage can after you get it.
I have a Hegner that I have all the pieces for that goes for almost $3,000. So, and it doesn't do a whole lot more than that does other than the bed's long.
Right. Well, that's one thing he's going to do is he's going to add 4 inches to this bed so that you can actually get a decent-sized spindle on here.
I'd like to see it half that size.
Me too. Well, I was kind of disappointed when I saw this because we had talked jewelry scale, but I think for him to even, when I met him 2 years ago, he kind of looked at me and he said, "What are you doing on that lathe?" And I said, "I'm going to spin some metal." And he said, "You can't spin metal on this lathe." And so I went out for a canoe ride and got it all out of my system, doggone it, or went back and just kind of started working on the lathe, and he began to realize that his lathe was capable of this process, and it opens up a whole nother possibility. So to get him to work this small was kind of a miracle, maybe because he's thinking all the wood turners want bigger lathes.
Yeah.
But I think with a smaller jaw chuck, I think that it would be very, very manageable on a small scale.
That's a commercial chuck, isn't it?
They make them,
Oh,
the
they make
Stronghold
the chuck?
chucks. Yep. That's what his business started out at, is making chucks for other lathes, like for General. What was interesting, I thought, at that conference is that there were 16 lathes, 9 of them were one-way lathes, and the other 7 were General lathes, and there were people standing in line waiting to use the one-way lathes. The Generals weren't used at all, which was, I thought, a
It's a
real...
very telling issue.
How small for jewelry would you get them?
Well, I think with the wooden forms, I mean, I could take this wooden form down to as small as you wanted it to be and say this tailstock, this little pin here could be the base. So all you would have to do is scale down to smaller tools. So I think now that I've seen it used a little bit, he's probably right, and this gives you the ability to spin a goblet. This gives you the ability to do candle holders. I still think you could get small. The reason why I didn't make any forms this small, and I certainly could, is just so that you guys could see. I was afraid that even on this scale it would be too small for you. But there's no reason why you can't make things this size.
But how small does that chuck go?
Get this kind of, oh, that's better. It's a really good question because the chucks that I have on my bigger lathe close up so that you can hold something that's about 1/4 of an inch. This one's only about 2 inches. But what you do is you take the wooden form in there and then you just taper it down and work off of something a little bit longer. You know, and when I'm making my patterns for the big pieces, I'm spending $100 on maple for my big patterns. This here, you know, this is my scrap that I've got that I'm using here. So you're not talking about a lot of money to taper that down. And once again, if I were going to do multiples of anything this size, I would certainly consider buying brass stock this size and turning it down so that you've got a brass form to work off of. Because these will last, but you're only going to get maybe 15 or 20 forms off of this before it breaks down. And one interesting thing about the wood is over the years, some of my most favorite patterns, I got a piece back to repair, and it's a little bit bigger than the pattern is now, so the wood compresses over time a little bit. So that would be an issue also that wouldn't be the case if you did it out of brass or out of steel. Well, welcome to Seattle, you guys that are from out of town, and the people that were fortunate enough to get into the conference. I just think it's great, and the people that didn't, I want you to know there are a whole bunch of Seattleites that are very disappointed too. Yeah, I sent my money in early. I knew that. I knew the conference would be just like Seattle. Too big for itself. Too crowded. So anyway.
That was shocking.